Good morning, friends. Today in this lecture, we are going to discuss a topic of classifications of drought and dust colors, dust collector, and types of dust collectors. See here, coming to the classification, the draft has been classified into natural draft as well as an artificial draft. And again, this artificial draft has been subdivided into two types as steam jet and mechanical draft, which is mechanical draft is nothing but of which where we are using there the fan draft. This steam jet again has been divided into two types as induced draft, forced draft. And again this mechanical draft has again been divided into three types as induced fan draft, balanced draft, and forced fan draft. This is what about the classification of draft, how the draft has been classified here. We are going to discuss about this natural draft and artificial draft in a detailed manner. See here, coming to the artificial draft, if the draft is produced by steam jet or fan, it is known as an artificial draft. If the draft is going to produce by the steam jet or fan, by using of fan, if we are going to produce the steam jet, then it is going to be named as an artificial draft here. Coming to the steam jet draft, it employs steam to produce the draft. Means here the steam is going to produce the draft in steam jet draft. And coming to the mechanical draft, it employs fan or blowers to produce the draft. Means in mechanical draft we are using here fans or blowers for producing the draft. In induced draft, the fluid is drawn through the system by fan or steam jet. See here, means sucking by using of fan or by using of the steam jet, the fluid is drawn through the system by a fan or a steam jet is nothing but of an induced draft here. Forced draft means we are forcing by using the air is forced into the system by a blower or steam jet. Means here by using of the blower or steam jet we are forcing the air into the boiler. Means nothing but of forced draft. These are some of the artificial drafts which we are using here in the classification of drafts. See here, coming to the natural draft, we can observe here how the chimney has been here, how the furnace grate level and the column of coal at the atmospheric air, column of hot gases after burning of the fuel. What are the hot gases produced here? We can observe here in the diagram itself. The natural diagram. Natural diagram system employs a tall chimney as shown here. Here we can observe a tall chimney here. The chimney is a vertical tubular monsory structure or reinforced structure. See here, it is in a vertical position. What is the chimney we are observing here is a vertical tubular reinforced. It has been constructed by using of reinforced concrete here. It is constructed for enclosing a column of exhaust gases to produce the draft. Here, how we are using here these means for this chimney, under the chimney, the draft is going to be produced. Okay, the draft is going to be produced. It discharges the gases high enough to prevent air pollution. See here, by using of these, we are going to prevent air pollution and the gases which are discharges into the atmosphere. The draft is produced by this tall chimney due to temperature difference of hot gases in the chimney and cold external air outside the chimney. The draft is produced by this tall chimney. See here, in this chimney, we are going to get the draft here due to temperature differences of hot gases inside the chimney and cold external air outside the chimney. See, we can observe the difference temperatures inside the chimney as well as in the outside of the atmosphere. Due to these temperature variations between inside of the chimney and outside the atmosphere, we are going to form a draft inside this tall chimney. This is what about the natural draft. Naturally, the draft has been produced inside the boiler due to the temperature differences inside and outside of the chimney. This is what about the natural draft in the heading itself. By studying, by knowing the definition itself, or by naming, by using of the natural draft name itself, we are telling that the draft is going to be formed naturally as the temperature differences between inside of the boiler and outside due to atmospheric conditions. This is what about the natural draft which we can say. See, and coming to the artificial draft, it has been seen that the draft produced by chimney is affected by the atmospheric conditions. See here, the draft which is produced, the draft is going to formed inside the chimney. What is the draft which is produced by the chimney is affected by the atmospheric conditions, as we are having some temperature differences between inside the chimney and outside of the chimney. See, it has no flexibility. There is no flexibility, poor efficiency, and tall chimney is required. For getting the draft, we need to require a tall chimney should be required there for producing a draft inside this chimney. In most of the modern power plants, the draft used must be independence of atmospheric condition, and it must have greater flexibility to take fluctuation loads on the plant. This is what about the natural artificial draft which we can see here. See, 20,000 tons of steam per hour would be impossible to run without the aid of draft fans. Without the aid of draft fans, how, by using of these draft fans, we are going to transfer the heat which has been developed here inside the boiler. That for this artificial draft, for running of the power plants, it is impossible to run without the aid of the draft fans here. A chimney of a reasonable height would be incapable of developing enough draft to remove the tremendous volume of air and gases. Here, the draft which we are using is used to remove the tremendous volume of air and gases inside the chimney. Without it is impossible without the height of the chimney. See here, the draft required in actual power plant is sufficiently high and to meet high draft requirements here. Some other system must be used. See here, the draft, what is the draft which we are using or developing in the chimney is required there for getting this natural draft, and some other times we are going to use this artificial draft also. The artificial draft is produced by a fan and it is known as mechanical draft. See here, we are using here artificial draft. The artificial draft which we are using here is nothing but of a mechanical draft. In artificial draft, we are using here fan. By using of the fan only, we are going to get the air or gases here. Mechanical draft is preferred for central power stations. This is what about the artificial draft. And coming to the forced draft here, we have studied in the previous class about this forced draft. That see here, forced draft. Here, by using of the blower fan, we are forcing the gases. So see here, we are forcing what is the gases produced here. We are forcing that gases by using of this economizer to air preheater and air preheater to the chimney and to exhaust to the atmosphere. This is what how we are going to force. By using of the blower fan, we are forcing the hot gases to enter into the chimney here. This is the boiler. This is the grate. Upon the grate, we are going to do some combustion process. After combustion has been takes place, here the hot gases are produced. What are the hot gases produced here has been entered into the economizer. By using of the economizer, it transfers into air preheater, and from the air preheater it transforms into the chimney, and from chimney to the atmosphere the hot gases appeared into the atmosphere. Means forced draft means by using of this blower fan we are forcing the hot gases here. In forced draft system, a blower is installed near the base of the boiler. See here, a blower is installed near the base of the boiler and air is forced to pass. Here we are forcing the air is passed through the furnace. See here, the air we are forcing here upon to the grate, flues, economizer, air preheater and stacks. By using of this we are passing these hot gases into the chimney here. This draft system is known as positive draft system or forced draft system, because the pressure and air is forced to flow through the system. See here, why we are naming here forced means nothing but of we are forcing by using of this blower, because the pressure and air is forced to flow through the system. See, the arrangement of system is shown in figure. A stack or chimney is also in the system as shown in figure. See, we are having stack and chimney, but its function is to discharge gases high in the atmosphere. Means as it is very tall, as the chimney is very tall, we are discharging gases at a very high in the atmosphere to prevent the contamination. Means to prevent the atmosphere, to prevent the pollution in the atmosphere. It is not much significant for producing draft, therefore height of the chimney may not be very much. See, by using of these blower, we are going to force the hot gases upon to the atmosphere. This is what about the forced draft. And coming to the induced draft, here in this system, see here, induced draft, the air enters upon the grate, and upon the grate combustion has been takes place. After the combustion has been takes place upon the these grate furnace, the hot gases which are generated here, we are giving the primary air as well as the secondary air upon the grate for combustion, for completing the combustion process upon the grate. Here we are having the boiler, and here we are having the boiler, and after what are the hot gases produced has been entered into the economizer, and through economizer it is going to be entered into the air preheater, and by using here we are using here blower. In front of this tall chimney, we are using here blower for pumping the hot gases or for entering the hot gases into the chimney, into this tall chimney, and forcing the hot gases to disperse into the atmosphere by using of this chimney. This is what about the induced draft here. We can observe the difference between the here a forced draft and induced draft, that what is happening here. In this system, the blower is located near the base of the chimney. We can observe here the base. At the base of the chimney, the blower has been instead of near the grate. In the previous forced draft, we are having the blower near the grate. But coming to the induced draft, we are having the blower near the base of the chimney. The air is sucked in the system by reducing the pressure to the system below atmosphere. The air is sucked in the system. Here, the air is going to be sucked in the system by reducing the pressure to the system below atmosphere. See here, the induced draft fan sucks the burned gases from the furnace, and the pressure inside the furnace is reduced below atmosphere and induces the atmospheric air to flow through the furnace. See here, the induced draft fan can suck here. The induced fan is there in the blower. The induced draft fan sucks the burned gases from the furnace. What is here in the furnace? We are going to complete the combustion process from what are the hot gases generated here. What are the hot gases which has been generating here upon the furnace combustion process. At the combustion upon the grate is reduced by, see here, air to flow through the furnace. The action of the induced draft is similar to the action of the chimney. See here, the induced draft is same as that of action of the chimney. The draft produced is independent of the temperature of the hot gases. Therefore, gases may be discharged as cold as possible after recovering as much heat as possible in preheaters and economizers. See here, this is what about the induced draft. That induced draft in the blower itself, we are having an induced draft fan. It is going to suck the burned gases from the furnace, and the pressure inside this furnace is reduced below atmosphere, and induces the atmospheric air and induces the atmospheric air to flow the furnace. See here, means what is the air which we have used here in the furnace is by using of the, as after generating the hot gases by using of chimney, we are sending the exhaust, we are sending the hot gases to the atmosphere, and we are going to get a new air into on the grate for for the other compression process in the boiler itself. See, therefore, gases may discharge as cold positive after recovering as much heat as possible in preheater and in economizer. See here, this is what about the balanced draft by using of here these FD fan. We here we are having, we are forcing, we are going to balance here by using of these. We are using the grate here, furnace, boiler, economizer, air preheater, ID fan, chimney. By using of this FD fan and ID fan, we are going to balance this draft fan. See here, it is always preferable to use a combination of forced draft and induced draft. See here, we are using both forced draft as well as induced draft fans here in the for discharging the hot gases, for discharging the hot gases which has been produced upon the grate and upon to the chimney by using of the economizer as well as preheater to the atmosphere by using of this chimney process. See here, balanced draft means we are balancing here by using of two fans, still nothing but of forced draft fan and induced draft fan. See here, instead of force or induced draft fan alone, if the forced draft is used alone, then the furnace cannot be opened either for firing or inspection. See here, if we are going to use here only forced draft, the furnace cannot be opened for completing the process. Because of the high pressure air inside the furnace will try to blow out suddenly, and there is a very chance of blowing out of the fire completely and the furnace stopped here. This is what for this purpose, for high pressure air inside the furnace will try to blow. For that process we are using here both the fans for balancing the draft here. If the induced draft is used alone, then also furnace cannot be opened either for firing or inspection, because the cold air will try to rush into the furnace as the pressure inside the furnace is below atmospheric pressure. This reduces the effective draft and dilutes the combustion. Here we are having two disadvantages, that if the forced draft is used alone, the furnace cannot be opened there for firing or inspection, because high pressure air inside the furnace will try to blow out suddenly. And coming to here, if we are going to use reduced draft alone, here the cold air will try to rush into the furnace as the pressure inside the furnace is below atmospheric pressure. This is going to reduce the effective draft and dilutes the combustion process. This is what about the balanced draft here. And coming to the next topic is about cyclone firing. Here cyclone fires furnaces needs coal in a spiral manner into a combustion chamber for maximum combustion efficiency. See here, in cyclone furnace we need for every combustion process we need solid fuel. Here also in the same way for cyclone firing we need a feed coal. We are going to feed a coal upon the combustion chamber for maximum combustion efficiency. See here, a cyclone furnace consists of a horizontal cylindrical barrel. Here you can observe this, a cyclone furnace consists of horizontal cylindrical barrel attached through the side of a boiler furnace. See here, near the boiler furnace, a cyclone furnace is having in the shape of horizontal cylindrical barrel. See, crushed coal and a small amount of primary air enters from the front of the cyclone into the burner. See here, what is the pulverized coal or small amount of primary air which is going to be entered into the cycle in front of the cyclone. The burner is there. The coal and air is entered into the burner. In the main cyclone burner, secondary air is in the main cyclone burner, secondary air is introduced tangentially, causing a circulating gas flow pattern. See here, we are having the main flow air, primary air enters here for combustion, complete for completing the combustion completely. And we are having the secondary air which is introduced here in the tangential way for circulating the gas flow pattern here. Coal particles thus have drilling motion. Here, this is what about the cyclone furning, how it does. The products, flue gas and uncombusted fuel leave the burner and pass over the fuel tubes here. The tertiary air is then released further downstream to complete combustion of the remaining fuel, greatly reducing NOx formation here. A layer of molten slag coats the burner and flows through traps at the bottom of the burners, reducing the amount of slag that would otherwise form on the boiler tubes. This is what about the cyclone furning, how it is going to be done. See here, I have told you that the primary air which is going to be entered here in the combustion zone, how the combustion air is going to be in tubes, in flue tubes, how it is going to pass here. See, you can observe that the primary air enters in two ways. That after the here after entering here, the cool air and the dilution air which we are having here enters into the combustion chamber, and the fuel which we are passing here, and these here by using of this we are going to do a cyclone combustion process here. This is the dilution air which has been entering through the side of the cyclone combustion. This is what about the cyclone combustion process. Here we can observe that from the side air, the primary air is entered here from this, and the secondary air also is going to be entered here. Primary air, coal and all, by using of this, the combustion process has been takes place, and hot gases are sent to the the atmosphere by using of this chimney, and the water which is going to circulate around these the tertiary air, and it's enters into the boiler for generating the feed water into steam. This is what about the cyclone process. And coming to the next topic is about dust collectors. Coming to the dust, what is mean by dust? Dust is a dust particle is a fine particle that is released, transported into the air, either entertaining with a product displacement of air because of the product in conveying air into the other processing equipment. Means how the dust is going to form here, and how the dust is going to be entered into the air is nothing but of the dust which we are taking here. Why is dust a problem? Means dust, why it is very problem for human beings. The dust means nothing but of the human beings are going to get the health issues for workers, safety issue for assets and facilities. For maintaining the dust, we are going to be, see, for maintaining these, they are having some dust problems, and equipment life is also disturbed by using of this dust. See here, coming to here, why we are using the dust collector here for collecting the dust means for improving the efficiencies. If we are going to face a lot of problems by using of by inhaling of these dust particles into the body. See, for getting lot of health issues and problems, we have created a dust collector for collecting the dust into it. See, a dust collector is a simply huge machine to collect tiny dust that are present into air or gas. What are the dust particles which are present in air or gas? We are going to collect by using of this dust collector in big industries. This way, various industries collect dust and the other impurities and helps to increase the quality of air released. What is the air which is going to be released? We are going to increase the quality of the air by removing the dust particles and impurities in the air by using of this dust collector here. These are basically designed to handle high volume dust loads. It has parts such as blower, dust filter, a filter cleaning system, and dust removal system. These are some of the parts which we are using here: blower, dust filter, a filter cleaning system, and dust removal system are some of the dust collectors which we are used here for collecting dust particles and impurities here. And such a big industry, there are variety of dust collectors used. Below are the types of dust collectors that are used here. We can here see what is meant by a dust collector. An air cleaning device used to remove heavy particulate loadings from exhaust system prior to discharge. Means what is the by using of this air cleaning, we are going to remove heavy particulates loading from the exhaust systems for discharging upon to the atmosphere. This is what how we are using the dust collector to discharge the impurities which has been found in the air. Functions of dust collector. What is the function of a dust collector? Means separating particular particles from the gas stream by deposition on a collection surface, retaining the deposited particles on the surface until removal, removing the deposit from surface for disposal. See here, we are having a definition of the dust collector here. A dust collector is a system used to enhance the quality of air. For getting the quality of air, we are going to remove the dust particles which is upon the air from industrial and commercial process by collecting dust and other impurities from air or gas. See here we are having these dust particles have been divided here into five types as inertial separators, fabric filters, PET subscribers, unit collectors, electrostatic precipitators. See here, these are some of the types of collectors, types of dust collectors which we are using here. Inertial separators. This type of dust collectors uses some external force. See here, we are using some external force for using of this inertial separators to separate the impurities from gas streams. From gas streams for collecting the dust, we are using here such type of inertial separators for separating the dust impurities from the air or gas. See here, these forces move the dust to an area where the forces exerted by the gas stream are lowest. See, then these separated dust are moved to the hopper for storage. What is the dust particles which are being collected by using of these initial separators are shifted or moved to the hopper for storage purposes. There are also further classification of inertial separators such as settling chambers, Beffel chambers, and centrifugal collectors. These again, these inertial separators has been subdivided into settling chambers, Beffel chambers, as well as centrifugal chambers. Coming to the fabric filters, these are the dust collectors which are used to separate dust particles from dusty gases. See here, these dust collectors are used to collect the dust particles from the dust gases, and these are also known as bag houses. Fabric filters are nothing but of a bag houses which we are most widely used in the industries. They are one of the most efficient and cost-effective dust collectors that can be used here. See here now, as the dust has been collected, it has been removed. There are various techniques to perform this activity as well as shaking, reverse air, pulse jet, sonic, cartridge collectors. So see, for removing the dust in the bag filters, we are going to use these shaking, reverse air, pulse jet, sonic, cartridge collectors, etc. Here, this is what about the next type of a dust collector is nothing but of a wet scrubber. In this system, the scrubber liquid comes into contact with the gas that contains dust particles. See here, in scrubber liquid comes into contact with a gas that contains dust particles here. Greater contact of the gas and liquid tends to higher dust removal efficiency. Here, The gases then are passed through a eliminator to remove water droplets from the gas, the dirty water from the subscriber system. Dust is removed from the scrubber in a clarification unit. Here both systems have solid element settle on the bottom. A drag chain system removes the sludge and deposits into the dumpster or stalker pile. This is what about the wet scrubber. Wet scrubber means nothing but of a liquid form. Coming to the electrostatic prespirators are one of the types of the dust collectors which we are using in different industries. That electrostatic prespirator is a process by which we can separate the dust particles from gas exhaust by the external force such as electrostatic force. We are going to collect the dust particles from exhaust gas by the external force such as electrostatic force. We are using the electrostatic force here, and we are going to collect the exhaust gas which has been produced in the externally, means outside of the boiler. See here, the contaminated gases afterwards flow through the passage which discharges electrode creates. See here, the particles which are burned in air receives a negative charge as they are allowed to pass through the ionosphere field. Further, these charged particles are then attracted to a positively charged electrode. See, we are having the other collector which is named as unit collector. Their small unit collector is a small collector and consists of a fan and some form of dust collector here. They are suitable for various operations such as for isolated and for portable or frequent. These are less expensive as well as less efficient here. These are differentiated into two categories as fabric collectors and cyclone collectors. These unit collectors. This is what about what we have studied in this video about the three topics of these classification of draft, that what is meant by an natural draft and artificial draft, and the subdivisions of natural draft as well as the artificial draft. And coming to here, we have studied about the cyclone firing, how the cyclone firing is going to takes place upon the grate in the combustion chamber. See here, and coming to the dust collector, what how we are going to collect dust particles in different parts and in different manner. um, how we are going to collect the dust particles and the types are functioning of the dust collector here. How the dust collectors has been divided into as inertial separators, fabric filters, wet subscribers, and electrostatic prespirators, and unit collectors. This is what about the and this is what about what we have studied in this video about the classification of draft dust collector and types of dust collectors. Thank you. If you are having any doubts, please contact me.